Welcome back to my channel. This is Tutor ID. Today we're going to be answering some questions on separation techniques. Yes, separation techniques is used to separate substances that are mixed physically together. First question is, filtration can be used to separate a dissolved solid from a solution, B, a soluble solid from a solution, C, an insoluble solid from a solution. And the answer, of course, is an insoluble solid from a solution. Yes, filtration can be used to separate an insoluble solid from a solution. Now the next question is, after filtration of sand and water mixture, the sand is left in the filter paper. The sand is the what? A, residue, B, filtrate, and C, deposits. And the answer, of course, is residue. Yes, the sand is the residue, what is left behind in the filter paper. Our next question is, after filtration of sand and water mixture, water that flows into the conical flask is called A, residue, B, filtrate, and C, deposits. And our answer is filtrate. Yes, what flows, the liquid that flows into the conical flask during separation or after separation of sand and water is filtrate. A separating funnel can be used to separate A, two immiscible liquids, B, two miscible liquids. And the answer, of course, is two immiscible liquids. Yes, liquids that cannot mix together. Example, we have water and oil. They are both liquid, but the oil will form layers. It won't dissolve in the water. The next question is, crystallization is a separation technique that uses evaporation to remove the solvent and recover the dash as crystals. A, filtrate, B, solute, and C, solution. Yeah, it is used to recover the solute as crystals. That is crystallization. The next question, a substance that dissolves into a liquid is said to be A, soluble, B, insoluble, and C, solvent. The answer is soluble. Any substance that dissolves into a liquid, dissolves completely, is said to be soluble. And any that does not dissolve is called insoluble. The next question, used to separate a mixture of compounds using a stationary and mobile phase is A, chromatography, B, decantation, and C, crystallization. The answer is chromatography. Chromatography uses movements to separate substances. It has a mobile and stationary phase. The next question is, the liquid that condenses during distillation is called the A, residue, B, distillate, and C, filtrate. The answer is distillate. Yeah, the liquid that condenses during distillation is called distillate. The next question, a mixture that contains suspended particles too small for filtration is A, colloid, B, emulsion, and C, filtrate. And the answer is colloid. Yes, that contains particles too small to be filtrated. For filtration is called colloid. The next question. A colloid in which one liquid is spread evenly through another and does not form layers is called A. Colloid, B. Emulsion, and C. Separating funnel. And the answer is emulsion. Yes, emulsion is formed when two colloids come together, whereby they don't form layers. So it's called emulsion. Emulsion are thicker than colloids. When you pour the liquid off the top, when sediments are settled to the bottom of the container, it is called A. Decantation, B. Emulsion, and C. Evaporation. The answer is decantation. Decantation is a separation technique that uses the principle where there are two substances that are immiscible. One is liquid and one is solid, whereby the solid settles and you turn out the liquid. Used to separate solid or liquid substances from liquid by spinning at high speeds. Substances are separated based on their weights. A. Decanter, B. Centrifuge, and C. Evaporator. Yes, a centrifuge. A centrifuge uses the principle of spinning mixtures based on their weights. So that is what the centrifuge does. Adding more solid to a solution will make it more A. Diluted, B. Concentrated, and C. Evaporated. Of course, adding more solutes to a solution will make it concentrated. Yes, when it's less, it's dilute, but when the solute is more, it is concentrated. The next question. A mixture of an insoluble substance dispersed in a liquid or gas is called A. Sediment, B. Suspension, and C. Insoluble. It's none other than suspension. Yes, when you pour substance in a liquid or a gas, from the word suspension, you suspend particles in liquid or gas. That is what is happening here. It's called suspension. Can a mixture be separated? A. Yes, and B. No. C. Sometimes. The answer is yes. Mixtures can be separated because they are physically joined. Mixtures are physically mixed together. They are mixed together, so you can separate them. They are not chemically bonded, they are physically bonded. A homogeneous mixture has the same composition of particles throughout. True or false? Yes, from the word homo, it is true. They are all in uniform. But heterogeneous mixture have different components. Yeah, homogeneous components or substances have the same components or particles. Look closely at this diagram. Now, in the distillation apparatus shown, what are the parts labeled A and B? A. Funnel, B. And thermometer, B. Thermometer and funnel, C. Liebig condenser and thermometer, and of course it's C. Liebig condenser and thermometer. You know what a condenser does? It converts gas back into liquid, and thermometer is for the temperature, taking temperature. Which one of the following is not an example of a separation technique? A. Surgical mask, B. Boiling an egg, C. Fishing net. And of course it's boiling an egg. Yes, a surgical mask prevents things from passing through, and also a fishing net is used for separating fishes from the water. So that's it. Now look at this diagram. Which technique is shown in the diagram? A. Filtration, B. Sieving, and C. Decantation. That diagram shows what technique? The answer is decantation. In decantation, there are two substances that mix. One is a liquid, one is a solid. The solid settles down and you turn out the liquid one. It's as simple as that. This question is: sand and gravel may be separated from each other using a separating funnel, B sieve, and C Liebig condenser. Yes, you can separate sand and gravel using sieve. Yes, sieving uses the principle whereby there are two solids that have different sizes. Yes, gravel and sand, they have different sizes, but they are both solids. Thank you for watching. Kindly subscribe and give us a big thumbs up.